What's going on, guys? Let's do this problem right here. The question is asking potassium metal has a work function equal to 3.68 times 10 to the power of minus 19 joule. What is the maximum longest wavelength in nanometer light that will eject electrons from K metal? So first of all, we have to know in which situation this light will eject electrons, right? So wavelength that will eject, so in which situation that will eject electron. To know that, let's put the equation first. So if I put kinetic energy equation, kinetic energy is equal to E photon. So photon energy, photon minus the work function, that is E naught. So this value mm, so this value right here, this should be greater than this one. So this should be greater than this work function. So if it's greater than work function, this will eject electrons. So this is the only situation that it will eject electrons. So to find that, what we can do, we can equate this kinetic energy to 0 and find the lambda in which situation this lambda makes the kinetic energy equal to 0. If I can find that, then I can determine in which lambda this is going to be ejecting electrons and not ejecting electrons, right? So let's find that first and let's discuss after that, right? So let's equate this one to 0, and instead of E photon I can put Hc over lambda, since we have the joules right here. This is work function, Hc over lambda. Lambda is the one we are going to find. We had work function, so we can find the lambda. So Hc over lambda minus E naught, that is going to be this value right here, 3.68 times 10 to the power of minus 19. And if I flip this around, like let's move this around and find the lambda. So let's bring this one to the other side, 3.6. Maybe before I do that, I arrange this equation in terms of lambda and then solve it, right? So E naught. So if I bring this one to the other side, this is going to be E naught is equal to Hc over lambda. Now I can find the lambda by using lambda is equal to Hc over E naught. Now I have the equation to find the lambda. So let's plug all the values. H is Planck's constant, that is always 6.626 times 10 to the power of minus 34 joule second. So let's plug that one right here. 6.2626 times 10 to the power of minus 34 joule second multiplied by the speed of light, that is 2.998 times 10 to the power of 8 meter per second, divided by the work function, that is 3.68 times 10 to the power of minus 19 joule. 3.68 times 10 to the power of minus 19 joule, and if you calculate this one, you will get 5.398 times 10 to the power of minus 7 meter, and they are asking in nanometer, so I had to multiply this one by 10 to the power of 9. If you multiply this one by 10 to the power of 9, you will get approximately 539.8. We can say 540 nanometer, right? Now we have the answer for the lambda. So which means if the lambda value is greater than this one, this will become smaller, right? This will become smaller than E naught, and at that situation, this light will not eject electrons. So this should be greater than E naught. To be greater than E naught, this lambda value should be 540. The longest should be 540. That's what we calculated. But other than that, it should be less than like 539, 529. 539, 538, below 540, whatever the value, that then it will eject electron, because hc over lambda, if you see the function, if the denominator, when the denominator becomes smaller, this value will become bigger, and that will be bigger than this one. And that's how we determine this wavelength. I hope you guys liked this video. See you next time.